Somebody's watching it. We will start from 9. 2 minutes of kindness, perhaps. We'll wait for 2 minutes. Kindly. Alhamdulillah. Okay. Here we go. Now we have been studying the pumping lemma for pumping lemma.
In
So pumping lemma, okay. What's going on here? So it's 8:59. Let's start now. All right. Let's do it. 31st of May.
the last
31st of May 2023. What is the time? 9 a.m.
lecture, we have studied about pumping lemma for context-free languages. And in this lecture, we will be taking an example to see and figure out how the pumping lemma for context-free languages actually works. So here we have an example language given, L equal to A power n, B power n, C power n, where n is greater than or equal to 0. So the meaning of this language is that we can have symbols of the form A, B, C, and then the number of A's should be equal to the number of B's, and it also should be equal to the number of C's. That means if you have n number of A's, you should also have n number of B's and also n number of C's. So it means the number of A, B, and C should always be the same. That is the rule of this language that we have. So our task is to show that this language is not context-free, and we will do this using pumping lemma for context-free languages. So let's see what are the steps that we need to follow. So the first step is we will assume that the language L is context-free. And why are we doing this? We studied in the previous lecture that the way we are going to prove this is using contradiction. So first we will assume that L is context-free, and we will show that there is a contradiction to our assumption, and hence it is not context-free. So we'll see how we do that. So first we have this language L and we assume that it is context-free. So if it is context-free, then the language L must have a pumping length. This also we studied, and we will call the pumping length P. And now we will take a string S such that S is equal to A power P, B power P, and C power P, where P is our pumping length. And then we have to divide S into 5 parts, U, V, X, Y, and Z. So let us just look at the rules of this pumping lemma that we studied in the previous lecture, just to recall those. So this is the rule of pumping lemma that we studied in the previous lecture. And we said that if a language is context-free, then it will have a pumping length. So we already assumed that our language is context-free, so it will have a pumping length P. And then we have to divide our language into 5 pieces, U, V, X, Y, and Z, which we will do. And after dividing that, you have to show that U, V raised to I, X, Y raised to I, Z also belongs to the same language for every I greater than 0. So this condition must hold if the language is context-free, and also condition 2 and 3 must hold. So we will focus on condition number 1. So let's go back to our problem. So here we have taken P as our pumping length, and we are going to divide our string S into 5 parts, U, V, X, Y, and Z. So let's see how we can do this. So here, for example, I have taken the pumping length P is equal to 4. You can take any other length also, but here, for example, we have taken our pumping length P, which is equal to 4. And so we have the string A power P, B power P, C power P. So all the P's I replace it with 4. So I have my string of the form A power 4, B power 4, and C power 4. So this is the string that we have, and our next step is to divide the string S into parts U, V, X, Y, and Z. So let's see how we can divide it. There are 2 cases. Case number 1. V and Y each contains only one type of symbol. So what do I mean by this? I'll show you. So here I've taken this string A 4 times, B 4 times, and C 4 times. So this is the string that we have. Now I'm going to divide it into U, V, X, Y, and Z such that V and Y each contains only one type of symbol. So let's see. I will take these two A's. This part will be my V. And then I will take this C over here, just this one C, and this will be my Y part. So what will be the remaining one?
U.
This A over here, this is my U, and this A, B, 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 and up to this C, this is my
X. Y.
X, and this two C's over here, this is my
Z.
Z. So I have divided my string into U, V, X, Y, and Z. And the case that we had was that V and Y each contains only one type of symbol. So where is my V? This is my V, and V contains only A, the same kind of symbols. And what about Y? Y also contains only one kind of symbol, which is C. So each V and Y, it contains only one type of symbols. So that is one case or one way in which you can divide it into parts U, V, X, Y, and Z. Now after we have divided, we said that the condition number 1 was saying that U, V raised to I, X, Y raised to I, Z must also belong to the language. So here I have I over here, and I am going to take I is equal to 2, for example. So if I take I equal to 2, that means it will be U, V square, X, Y square, and Z. Now let me replace it here and see what is the kind of string that I am going to get. So if I do this, U, what is my U? U is just one A. And what is my V? V contains two A's. But it is V square, so I have to double it. That means there will be four A's. A, 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 A. Then X. What is my X? A, B, 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 C. A, B, 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 C. And then I have Y square. What is my Y? Y is just one C, but since it is square, I have to double it. So there will be two C's. And then Z. Z contains two C's over here. C, C. Alright, so this is the string that we get. Now let me count how many A's are there. 1, 2, 3, 4, 5, 6. There are 6 number of A's, and how many B's? 1, 2.
जहां भी जाओगे पर जब लौट के
4. 4 number of B's, and 1, 2, 3, 4, 5. 5 number of C's. So this is the string that I am getting. So here I see that A is 6, B is 4, and C is 5. The number of A's is not equal to the number of B's, and that is also not equal to the number of C's. So the rule of our language said that the number of A's, B's, and C's should always be the same. But when I divided my string into U, V, X, Y, and Z, and when I raised this V and Y to the power of 2, the string that I am getting does not belong to the language L, because the resultant string that I get here has different number of A's, B's, and C's. So this does not belong to the language L. So this shows that condition number 1 cannot be satisfied. So since condition number 1,
I'm gonna write it all down. I'm miswriting that down on paper, man. Show what do we show? L equal to A power n, B power n, C power n, such that n is greater than equal to 1 is not. पहले assume करिए कि L context free है. Assume that L is context free. L must have a pumping length. लाइट कम है इस रूम में वैसे ऑनेस्टली।
one cannot be satisfied, we see that our assumption which said that L is context free does not hold. It is a contradiction to our assumption. If L was
हाँ यार देखो, अरे आंखों में देख रहा हूँ, आपको क्या हो गया? आंखों में देखने से ही पता चलता है ना क्या सोच रहा है सामने वाला। ऐसे थोड़ी पता, दूर से नहीं करना चाहिए ना, स्माइल के साथ देखो। आंखों से इंसान देखता है खुशी, और क्या मुंह गाल ये सब दांत दिखाना कुछ होता है, आंखें कुछ और, आंखें ही बोलती है
post.
सब कुछ, आंखें बोल देती है।
So this does
देखो
not
इस वक्त आप जैसे बहुत खुश हो, ऐसे ही
belong
रहो।
to the language L, because the resultant string that I get here has different number of A's, B's and C's. So this does not belong to the language L. So this shows that condition number 1 cannot be satisfied. So since condition number 1 cannot be satisfied, we see that our assumption which said that L is context free does not hold. It is a contradiction to our assumption. If L was supposed to be context free, then the string that I get here should also belong to the language L, but it is not belonging to the language L when I do this. So our condition number 1 itself fails. If you want, you can check conditions number 2 and 3 also, but since 1 already failed, so there is no point in actually checking 2 and 3. So from said that L is context free, supposed to be context free, then the string that I get here should also belong to the language L, but it is not belonging to the language L when I do this. So our condition number 1 itself fails. If you want, you can check conditions number 2 and 3 also, but number 1 itself to check now, and condition number 1 says that if I raise u v raised to I x y raised to I z, then this resultant string that I obtain for context-free languages. So what is a pumping lemma for context-free languages? Pumping lemma for context-free language is used to prove that a language is not context-free. So if you remember, we have already studied about pumping lemma for regular languages, where we use the pumping lemma to prove that a given language is not regular. So if you have not watched that video and if you need to study about that, you can watch it in this playlist. And if you have already watched it and if you have already studied it, then this pumping lemma for context-free languages should not be a difficult topic for you, because the pumping lemma for context-free languages is almost similar with that of the pumping lemma for regular languages, but yes, there are a few differences. So we shall see what they are, and we shall see how we can use this pumping lemma to prove that a language is not context-free. Alright, so let's see how we can do it. If A is a context-free language, then A has a pumping length P such that any string S where the length of S is greater than or equal to P may be divided into 5 pieces S equal to U, V, X, Y, and Z such that the following conditions must be true. So what we do is, let's say that we have a language called A. So we say that if A is a context-free language, then A will have a pumping length P. So we don't know what is the pumping length P, but it will have some pumping length such that any string S, so S is a string from this language A where the length of S is greater than or equal to the pumping length P, that string S can be divided into 5 pieces such that S equal to U, V, X, Y, and Z. So if you remember, when we studied for pumping lemma for regular languages, we divided the string into 3 pieces. But in this pumping lemma for context-free language, we will divide the string into 5 pieces, U, V, X, Y, and Z, such that the following conditions must be true. So if you divide it into 5 pieces like this, these 3 conditions must be true. And what are they? U, V raised to I, X, Y raised to I, Z is in A for every I greater than or equal to 0. So you have divided S into U, V, X, Y, and Z, and here if you raise V to the power of I and Y to the power of I, where I is greater than or equal to 0, then the string that you get even after doing this should also be in A. That means that string also should belong to the language A. And the second condition says that the length of V and Y should be greater than 0. And then the third condition says that the length of V, X, and Y should be less than or equal to P, which is our pumping length. So remember that this U, V, X, Y, Z, they are not strings, but they are the parts into which you have divided the string S. And after you divide this, these 3 conditions must be true. And if these 3 conditions are true, then we can say that it is a context-free language. So we are going to prove that a language is not context-free using this pumping lemma. So this is the
ओ भाई, मैं वादा करता हूँ कसम से, क्या बोल दिया यार मैंने।
the conditions that we know,
Right?
and let's see how we can prove it using
Stay
pumping
away from power
lemma.
and all that.
So, in order to prove that a language is not context-free using pumping lemma for context-free languages, we have to follow the steps that are given below. So, just as we did in the case of pumping lemma for regular languages, even in this case, we will prove it using contradiction. Alright, so here we have the three conditions given and we already defined them. And now, since we are going to prove it using contradiction, what we will do is we will assume that A is context-free. So, we have a language that we call A, and we will assume that it is context-free for the beginning. So, we have already read that if a language is context-free, then it has to have a pumping length, and let's call it P. So, as we assumed A is context-free, so it should have a pumping length, which we will call P. And then all the strings longer than P can be pumped. So any string whose length is greater than or equal to P can be pumped. That's what we read above. Now what we will do is we will find a string S in A such that the length of S is greater than or equal to P. So we have our language A, and from this language A we will take a string which we will call S such that the length of this string S should be greater than or equal to P, which is our pumping length. Now after you take that string S, we will divide that S into 5 parts: U, V, X, Y and Z. So we have a string and it is divided into 5 parts now. Now we will show that U, V raised to I, X, Y raised to I, Z does not belong to A for some value of I. So you have divided this S into these many parts. So when it is divided in this way, it is lying in this language A. We know that. Now we will show that this string S, which you have divided into these 5 parts, this part of V and this part of Y, when you raise it to some power of I, that means if you repeat this V part and Y part some I number of times, this new string that you obtain, you have to show that it does not belong to the language A. So we don't know what is the language right now, but when you have the example, you will know some rules that have to be followed for the language. So once you divide it in this way and raise it to these powers, you have to show that it does not belong to this language A. After that, consider the ways that S can be divided into U, V, X, Y and Z. So this string S, when you divide it into U, V, X, Y and Z, there are many ways in which you can divide it into these 5 parts. So consider all the ways in which you can divide the string S into these 5 parts, and after you find them out, show that none of these can satisfy all the 3 pumping conditions at the same time. So what are the 3 pumping conditions? These 3 conditions that we have read over here. So once you find all the ways in which S can be divided into these 5 parts, show that those divided parts cannot satisfy these 3 conditions of pumping lemma at the same time. So since it cannot satisfy all the 3 pumping conditions at the same time, S cannot be pumped, which is a contradiction to our assumption that A is a context-free language. If A is a context-free language, then it should be able to be pumped. But since we find that it cannot be pumped, we get a contradiction. Thus, we prove that A is not a context-free language. So these are the steps that you have to follow in order to prove that a given language is not context-free using the pumping lemma for context-free languages. So don't worry even if you feel a little bit confused seeing all these rules and steps. In the next lecture, we will be taking an example in which we will clearly see how to perform these steps in order to prove that a given
9:30 हो गया, so now I'll take a 6 or 7 minute break. Session 2 will start in 8